Welcome to the first presentation in Unit 4 entitled A Momentous Occasion. It says one way to keep momentum going is to constantly have greater goals. Michael Korda, who's a famous physicist. So the learning goals for this particular presentation are that you be able to distinguish between inertia and momentum and use the momentum equation, which is shown right here as P equals mv. So here's what we already know. So we already know from previous units that mass is measured in kilograms and that all objects have mass. In fact, mass is a measurement of matter. And since all objects are matter, they're all going to have mass. In addition to that, we know that velocity is measured in meters per second and that velocity is a vector. And since it is a vector, it includes both a magnitude, which is a number like 10, and a direction, which is like right or up or left or something along those lines. We also learned in the previous unit that kinetic energy is the energy of movement. So if something has some sort of velocity, then it is also going to have some sort of kinetic energy. So here's what we learned in the lab. Increasing the mass of the ball, so if you had a ball right here, if you increase the mass of the ball, making the ball larger, not just physically larger like in terms of dimensions, but also in terms of mass, it actually gave the ball more momentum. It was more difficult to stop. Increasing the angle increased the velocity of the ball and therefore made it more difficult to stop. And increasing the distance that it was allowed to roll, so if you started it here versus here, that actually increases the velocity as well and increases the momentum. So momentum is sometimes referred to as mass in motion because both are required. You must have both a mass and a velocity in order for you to have any sort of momentum. Momentum is actually calculated as the product, so we multiply mass and velocity together. And it requires that objects have both. Okay, if you have some sort of massless particle, which is something like light, it doesn't tend to have momentum as we traditionally think of it. Now, if you have something that has mass but isn't moving, let's say the school, then it doesn't consider to have momentum either. Momentum is a vector, and because of that, whenever you report the momentum of something, you should say, oh, the baseball is moving with 10, and the unit is kilogram meters per second, down. In other words, you should always indicate a direction as well as a number. Inertia, on the other hand, inertia tends to be mixed up with momentum. Inertia is the tendency of an object to resist change in motion. Now, you may remember this when we talked about Newton's laws. The first one of Newton's laws was Newton's law of inertia. And because of that, it says objects in motion stay in motion and objects at rest stay at rest. Well, mass is actually a measurement of inertia. An object can have a large amount of inertia and at the same time have zero momentum. Okay, because inertia does not require an object to be moving. So this guy who's sitting on the couch has zero momentum, but he has some sort of inertia because he has some sort of mass. So we come to the equation, and the momentum equation that we have is momentum is the product of mass and velocity, and momentum has a unit. It's a new one. It's called the kilogram meter per second. And the kilogram meter per second isn't directly measurable. It's one of the things that's a combination of things. Whereas mass, we've already talked about several times, is measured with a balance, and it has a standard unit of a kilogram. And then velocity is meters per second and can be measured indirectly using photo gates and radar. Okay, it says what are the units of the variable in the equation below. Now, one of the things that makes using an equation particularly easy is if you know the units. The units for momentum are the kilogram meter per second. So anytime you see something like this, you should automatically go, oh, that's where it goes in the equation. And if that's one of the tough ones that you have a hard time remembering, you should know that mass is measured in kilograms, which goes right there. And you should know that meters per second goes right there. How can you maximize the impact of the car on the block? Well, there's several different things you can do. You're trying to maximize the impact. And remember, momentum is mass in motion. It's a product of mass and velocity and results directly in a higher impact. So the more momentum, the greater the impact. So the way that I can increase the momentum of this car is I need to increase its mass and I need to increase its velocity. Now, increasing its mass is going to be kind of tough. I guess I could strap some weights to the top of the car, something like that. Or the other thing that I can do is I can increase its velocity. Now, if I'm looking at this particular ramp, I can actually elevate the ramp up. And by elevating the ramp up, I'm going to give it a greater acceleration and then therefore a greater velocity when it strikes the block. My other option is that I can actually take the car and I can move it further back. When I move the car further back, it has a greater distance to accelerate, and will therefore have a greater velocity. But the two things that I really need to focus on is increasing the mass and increasing the velocity as it strikes the styrofoam block. It says calculate the momentum of a 5 kilogram bowling ball thrown at 14 meters per second. So remember, whenever you work these problems out, we're looking at the guess method. So we'd say, okay, I want to know the momentum because I circle what I want to know. Momentum is question mark. 5 kilograms is a mass, and I know that because I can look at it and say kilograms is a unit of mass. Meters per second is a unit of velocity, so I can say v equals 14 meters per second. My equation that I have is momentum equals mass times velocity. So now I can plug in, I can say 5 times 14, or when you multiply all this out, you get 70 kilogram meters per second. And finally, it says create a Venn diagram comparing and contrasting inertia and momentum. So when you create a Venn diagram, you put one substance on one side, inertia, and the other one on the other. Now, whenever you do this, things that are in common between the two go in the middle of the two circles. So both of these things require mass. Momentum, on the other hand, requires velocity as well. Okay, inertia is what we call a scalar. It does not require any sort of direction at all. And a unit of this thing would be kilograms. Okay, momentum, on the other hand, is a vector. It does require some sort of direction as well. And the units for momentum are kilogram meters per second. Really, the only thing that they have in common is that they both have mass somehow involved in them.